Welcome back. Today we're going to do a slightly different kind of a video. Today, instead of covering any new concepts or creating a new demo, I'm actually going to show you how I have been drawing all these diagrams that keep popping up on my decks. There are two tools that I use. One is called Visual Paradigm, which is fairly consistent with the UML standard. And then the other tool is Lucidchart. And of course, they are competitors, so you will see things happening in those frames. Now, Lucidchart is a great cloud-based tool, but it is a generic diagramming tool. So you will have to be careful about what construct you use and make sure you use the right standard construct. So let's get started. Let's first take a look at visual paradigm. So if I search for visual paradigm, what is strange is that if you just search for visual paradigm, the first uh, sponsored response is actually a Lucidchart ad, so which is very, sneaky. But you want to use the second one, the visualparadigm.com. That's the visual paradigm site. Now, Visual Paradigm does have a commercial version, and they have a community edition as well. Of course, when you go to their site, they want to sell you the commercial version. So if you just go on Try Now, it will ask you to download the free trial of the Visual Paradigm commercial application. However, you can actually download the community edition free for non-commercial use. And for most practical purposes, it works pretty well. There are some advanced features that are not available. And if you export diagrams from the free version, it puts a watermark on there. But otherwise, you can use any diagrams, any number of diagrams you want. It is an application that you will need to download and install in your computer. So it is not a cloud-based product, although Visual Paradigm does have a VP Online, Visual Paradigm Online product. I do not use that, I have not used it. So that may have positives or negatives that I do not know about. But let's start up Visual Paradigm. Here is Visual Paradigm main page. Obviously, it is a community edition. What you need to do with Visual Paradigm first is to create a project. So we're going to create a new project called um, Pico Stopwatch. So when you first create the project, the screen doesn't really change, but you would see that on the top, it now shows the name of the project that we created. So a project consists of multiple diagrams. So you'd go to the diagram tab and click on new. And you will search for, obviously, I have used these three types of diagrams a lot, but when you first bring up, you'll probably not see these. So you just have to search for class, and the first match will be the class diagram. So what we're going to do is we're going to create a blank class diagram, and we will call it stopwatch class diagram. And you can put any description you want, but when you do that, it's going to give you a blank canvas with a number of these things already pre-populated. So you do not really need to do much in terms of finding the proper shapes to use. So what I'm going to do is create a very simple model view controller type of design for a stopwatch. And we'll talk as I'm drawing it. I'm going to talk through why I'm picking it this way. Remember, we're probably not going to have the entire diagram created, but what I might do is at the end of this video, show you what a complete diagram might look like. But let's go ahead and create our first class. So obviously a stopwatch, you will need some kind of a stopwatch model class, right? So a model class is something that is going to be okay to use for any kind of implementation. You do not want to put too much in terms of hardware or any specific platform in the model class. So I'm going to call this my stopwatch. What I try to first do is start with operations. What can you do with an operation? Well, obviously, you're going to have an init, and this is what I have been doing. And since we are using Python and we know for every application, every init or any method you want to use in an application, you would need to put self as the first parameter. We're just going to go with that understanding and not put self in the methods. When you implement them, just make sure that the first parameter is always going to be self. So let's say it has an init. We don't know what parameters it would need, but let's see what types of things you would want to do with a stopwatch. So if I just search for, let's see what this does. So here is a simple stopwatch. Click on play. Again, this one only has a play button, does not have a clear button. So let's click on play. And now when I click on play, notice that now it gives me the two buttons, one for pause and one for reset. So you should have two buttons. The play button will change its functionality to pause, and then there is a reset button. Let's click on pause and see what happens. It has paused and it is showing the current time, and I can reset it and it goes back. So let's start with that. That seems to be a fairly basic functionality. So we are going to have a function called play. We are going to have a method called pause. And we're going to have a method called reset. So that's essentially all the functionalities that our stopwatch model will have. Okay, so that's the basic functionality of a stopwatch. Let's take a look at the view. So this is kind of the model. We're going to probably need more into the model. So let's look at the view. A view is what the user interacts with. Now, you obviously have a display, and there are two buttons, right? Now, when it's reset, it only shows one button, but technically there will be two buttons. So we will need to use a display. And since we know that we're going to be using the Pico library class, so let's look at the classes that we have. And we know that we have a display class. So there is the display class, but the display class is the base class, and you do not, you can't just use that display class. You're going to use a very specific subclass of that class. So here is a display class, and it has a subclass called LCD display. And it's got methods like reset, clear, show number, show text, and scroll. So those are basically the methods. And when you initialize the LCD display, you need to send in the SDA and SCL like we have been doing. Of course, my LCD display class works with both the I2C, which is the serial version, or the parallel version, which needs 7 connections. So these are all these 7 connections that you have to provide if you are using the parallel method. 5 connections plus, VCC and negatives. But here are the methods: reset, clear, show number, show numbers with a colon and things like that, and show text. And then you can add custom shapes and stuff like that. So what we're going to do is instead of putting all the methods that display has, we're basically going to put the things that we need. So display so this is the base class display, so which we are likely not going to directly use, but since it does have that base class, it needs to be part of the model. So we have an init, and if you remember, it has a reset, clear, it has show number, it has show text, and it has scroll. Right, so those are the base class display. Now what we're going to do is create that subclass called LCD display. Now this one has an operation. Of course, it has an init. And this time we're going to add the SDA and SCL parameters. But let's just add the other operations that we need. We will need the reset. I think there is a slight distinction between reset and clear. I think reset completely resets the display, and clear, you can clear a single line. So let's take a look. If you see reset, completely resets the display, and clear, you can pass in a line that would only clear that line and not the entire. So that might be useful. Clear, and that takes a parameter called line. Then we need show text. And it has show number and all of the other things. We don't need them. So in this model, I'm not going to show all of them. Now, LCD display is a subclass of display. So we need to show that generalization, right? We learned about generalization, and the way you use that is you click on this generalization and then just go connect from superclass to subclass, and it draws the proper arrow with the symbol that you need. You can provide some text to it, but for generalization, typically you do not need to say anything. Just this arrow with that big arrowhead tells you that this is a subclass, and that's the superclass. Now, we also need two buttons, right? So what we're going to do is we're going to add the buttons. Now, the button is a simple enough class. So let's take a look at the button class here. And here's the button class. It has an init with a pin and a name. It has a method called isPressed to see which whether it's pressed or not. And set handler, sets who does the handler. And this one is a callback method that you notice that underscore in front. That basically means that that's sort of a private method. Do not worry about, you should not call that directly. So that's a fairly simple class. So what we're going to do is we're going to create a class called button. And here is my button class. And I am only going to add the operations, of course, init. And init takes a pin and a name. The name is actually important. And then actually it takes an optional handler as well. So let's put that in there. If you look at it has pin, name, and a handler. And buttons also can be low active or high active. When it's pressed, whether it goes to low or high. But the good news is that when we use a button, all we care about whether it's pressed or not. So low active or high active, it depends on how you actually connect the button, which we will see when we implement it. But today we're just drawing the diagrams. So we're going to have an operation is pressed that simply returns whether it's true or false. So you can actually say bool here that sort of says that it's notice that not all of these we are providing types. And although in a proper object-oriented design, UML, you should provide types. But as you know, Python is not 100% object-oriented. It's not 100% typed. So we have kind of been laxed with that, which is fine. So we'll say set handler. That's takes a parameter for that handler, and then the callback method is a private method, so we do not need to worry about that. Now, I probably should also show you how to add private methods if you want to do this. Now, when you put something like this, let's say I want a callback method, right? And let's see what parameters does it have. Callback has a pin parameter. Okay, now this callback method is private. So what you should do is you should click on open specification and change the visibility to private, right? And when you do that, notice that the sign in front instead of a plus becomes a minus. Minus in UMLs represents a private method. Now, for many of our diagrams in this series of videos, we're not going to, bother too much about displaying private methods. We're only showing public methods. The other thing that you would notice that I'm just working with operations now, because operations are easy to understand. We can see them directly and what kinds of things they would be doing. So it's not that hard to understand operations. Now, attributes are things that are used to support the operations. So obviously, when you pass in these attributes there, they need to be stored somewhere. So let's go ahead and at least set up the attributes for the button class. So it should be fairly simple to do. Now in Python, attributes are actually set in the init methods. So, and they always start with self dot and then the name of the attribute. Now, again, I mentioned that Python is not a typical object-oriented language, which means it does not have those private, public, protected type of modifiers. So what they do is you put an underscore in front of an attribute to tell the users that this is a private attribute, do not directly modify it. Although it is still possible to modify, but if you don't, take into account. But let's look at all the attributes that it has. This self pin number is an attribute, name is an attribute. It has a pin as an attribute. There is a debounce time, low active, last status, handler. So you can see there's a whole bunch of attributes that I had to create in order to support all of the operations. So for the classes that are in Pico library, we're probably not going to do too much about putting in all the attributes in our diagrams going forward. But at least it's good to know where these attributes are created and supported. So at least for this diagram, for this method, let's just go ahead and say pin number. What else do we have? Name, pin, debounce time, low actives, last status, handler. Name, debounce time, low active, last status, and handler. Last status and handler. So these are all the attributes. I forgot to put the underscore in front. And the underscore basically says in Python that they are private attributes. Notice that by default, attributes are always private when you create them in Visual Paradigm, and methods are always public. But you can always go to the specification and change them to something different if you like. So attributes are typically kept private. So this is kind of the entire button class. Obviously, display and LCD display probably has other things. All right. For the stopwatch application, the stopwatch needs to keep track of time. So we looked at the counter class in the last video. We were doing the timing for the stoplight. It has lots of different classes, but one of the classes is called timekeeper. Timekeeper is actually something that allows you to keep track of time. It's really a simple. It has a start time and has something that says whether it's running or not. It's actually, not actually keeping time. The time is kept by the Raspberry Pi. The timekeeper simply remembers the start time and whether it's running or not, and based on that, it'll give you what it's able to do. I'm going to speed up and voice over through some of these parts where I am essentially going through the Pico library class source code and adding the attributes and methods for the counter and timekeeper classes. I will explain what the str class is about in a little bit and then speed up again. str allows you to create a string representation of your class. And you can put whatever you want in there. So whenever somebody converts your class into a string, this str method is going to be called. And we're actually going to use it when we go to implement our um, class. So let's do the generalization. Remember, timekeeper is a subclass of counter. So we're going to start from counter and take it down to timekeeper. All right, so this is all we have, at least for now, are the classes that we know we will need. The stopwatch is the main view or main model of the stopwatch. It uses at least for us, it's going to use one timekeeper. So we will start with our first association, and we're going to make this an aggregation because the stopwatch contains its timekeeper. Now, we could call it a composition as well, because if the stopwatch goes away, all of its timekeepers go away too. So let's do the proper thing, and we will say that stopwatch maintains timekeepers. All right, and we called it a composition. Just a quick reminder that what is a composition is where you have a whole part relationship, and the relationship is very strong. That means when the whole goes away, the part goes away as well, and you cannot take the an instance of the part out and use it somewhere else. So here, a timekeeper, this timekeeper is going to be only used for this stopwatch. You could technically use aggregation as well and explain that, but probably is not a generic association. Now, in order to pick a composition, what you will need to do is in Visual Paradigm, click on these little tiny black arrows, and that gives you all of the different different things that you can use with it. So let's use the composition for now. Now I said maintains. How many timekeepers can a stopwatch have? For our initial implementation, we're just gonna do the start, stop, and reset, right? So there's only one timekeeper that it needs. But and that's something strange that I did not see it in the base one, where you can actually have laps, right? As you're running, every time you lap, you can have multiple timekeepers that you can keep track of. So the next thing what we're going to do is implement the directionality and multiplicity constraints of each side. So a stopwatch can maintain multiple timekeepers, and that's what we are going to implement now. So when you double click on this side, you see a little end form that pops up, and that lets you change and do additional things with it. You can actually say what the multiplicity would be. Okay, so on this end, given a timekeeper, it will belong to either one stopwatch or may not belong to any. So we will put this 0 dash dash dot dot 1 on this side. So notice that it puts that 0 dot dot 1 over here. But here, what we will do is this one can need at least one timekeeper, but it could have multiple. So we will say 1 dot dot star. For the first implementation, we will only use one, but we will probably do more than one going forward. All right, so now we're getting pretty close to being done. So let's create what will bring our view, which is what the hardware classes are, which is what the users interact with. And here's the model, which is the completely conceptual version. It has nothing to do with hardware. So what we will need is something in between that we call a controller. So that is what going to keep the two, bring the things together. So stopwatch controller. Let's do one more time lapse through the creation of the associations between the stopwatch controller and the various classes that it connects to.
like stopwatch, we're just creating uh, a normal association for that. And then from stopwatch controller to display, we're going to create an aggregation. And from stopwatch controller to button, we will create one more aggregation. Um, Particularly watch how I change the aggregation of the button to use a very specific number. So for example, stopwatch controller contains or uses two buttons. So we're going to change the aggregation, the multiplicity to just say 2 instead of 1 dot dot star.
So that kind of shows the various associations with the aggregation. This one is a composition. Let's do one other thing that is going to show the directionality. In Visual Paradigm, directionality is pretty simple. You go to presentation option and then you say show direction. There you go. And it shows that arrow that says direction. Same with this. Presentation options, show direction, presentation options, show direction, presentation options, show direction. Okay, so that shows you which direction these goes. Now, when you create these directions, that actually does have a meaning, and that's what we're going to put in before as the final part of the class model is we are going to add the attributes that represent these associations. So as you can see, this one could have multiple timekeepers. So what we will say, we're going to add an attribute and we will create a list that says timekeepers, and that's a list. So I could have multiple timekeepers in my stopwatch. Or if you only have one, you could just say have one. That square bracket just tells you that it's a list. And that's what the one dot dot star means. Now in stopwatch controller, you see that there are three associations going out of it. So there are going to be three attributes that represent these associations. So we're going to add an attribute called stopwatch. Let's say my stopwatch. And if this was a proper timed you know, proper object-oriented language, you would say stopwatch here. That's the type of the stopwatch. Let's do it since we are kind of learning about object-oriented modeling as well. Let's take a look at the display. So you'd say and I'm calling it my just to, these are variable name. These are the internal attributes. My display, and this is of type LCD display. And finally, buttons. So there are two buttons exactly. So we'll create two attributes. So let's say button 1, or let's call it the start stop button. And let's call it the reset button. I could create a list of buttons to represent the two buttons, or since I know exactly two, I'm going to create two variables. And this, of course, this will have operations like an init to start the stopwatch and things like that. It is probably going to have all kinds of operations, but at least the ones that we know that we need is to receive the button pressed and button released. So let's say button pressed and button released. These are the handler classes, so methods that we need to do. When a button is pressed, we need to, this button is going to send a message back to the stopwatch controller saying that button was pressed. So at least we will need these two. We will likely need other methods as we go forward and go into actually implementing the stopwatch. But this is going to be the entire class model of the stopwatch. There's probably certain things that we have missed in here, but this is kind of what you will need to have for a complete model for your class. What I'm going to do is show you the same thing, but I will time lapse through it for Lucidchart. So for Lucidchart, what you do is you go to lucidchart.com, and if you do not have an account, you can sign up for free. The base Lucidchart will give you 3 free diagrams to use, but then if you want more than 3, then you will have to pay for it. But the nice thing is that Lucidchart is completely cloud-based, so there is nothing to install, and it's very good cross-platform, so it works pretty well in all kinds of platforms, including your tablets and mobile devices. Since I already have an account, I am going to go ahead and sign in. And I'm going to create a blank diagram, just show you how to add the class diagram context. So when you create a blank diagram, you will likely, actually, let's just clear these. You'll likely see some generic shapes in here. In order to find the shapes, notice that we created a diagram, a class diagram in Visual Paradigm. You got the whole plethora of classes that you wanted. Here, you have to add in UML class diagram. There it is. And that's the shape library that it uses. And basically that gives you that class shape, and you use these arrows to draw the classes. So I'm going to create the same class diagram in Lucidchart, but I'm going to just time lapse it for lack of time, but I'm going to create the same thing so you can see how I'm doing it. Okay, so you saw how I drew this diagram. There are a couple of things that I should point out here. In Lucidchart, it more or less supports all the shapes that you need, but you are in charge of making sure you're using the right shapes. You don't have the option of saying, oh, I'm going to use an aggregation and it uses the right shape for aggregation. So you will basically have to pick the correct shape by going into the drop down and putting in the shape that you want. Also, as you create the relationships, it shows you a pop-up that tells you to add the multiplicities, and that's how you add multiplicities. And again, you have to go in and put in the right multiplicity values. And to add the text of the association, you just double click and put in the text in there. If you do not see the multiplicities, you can just click on that association line and the multiplicities thing will show up, or you can click on this settings cog that will also show the multiplicity as well. But this is how you create a class diagram. In the next video, we are actually going to implement this in an actual system. Hope this was useful, and I will see you in the next video.